I'm going to do a short video key on Exadicate 13.1. This is Mr. Ward, and here we go. We're working on some of the early proof concepts, and you may or may not have gotten to these two concepts, but I talked about them in class, so we'll see if they make sense. They're fairly straightforward. If segments or angles are congruent, their like multiples are congruent. That means if you multiply a segment or an angle both by the same number, you scale it up or scale it down by the same number, the product will be congruent. So if I multiply two of the same things by three times the same things are the same things. Okay, so they'll be equal to each other. And because division is just the reciprocal of multiplication, we can use the same thing with division. So if segments or angles are congruent, they're like divisions. If we divide them by the same number, they are the quotients are also congruent. This is called the division property. So 4a. So oftentimes you're going to have to think about whether division or multiplication is involved. So we know that MP is congruent to NS in this picture. So here's MP. We know that is congruent to that. We also know that O is the midpoint of MP and R is the midpoint of NS. You want to think about, what does a midpoint do? A midpoint divides something into two equal parts. So essentially, we are dividing MP and we're dividing NS in half. And so MO and NR are both half of the same thing. So we would prove that because MO and NR are each 1/2, are each 1/2 of congruent segments. They are congruent. Okay, and you could probably make a case for this as multiplication or division, because 1/2 of is multiplication, or divide by 2. Okay, but probably by division. Okay, because if segments, wow, I'm having a little trouble typing here, because if segments are congruent, they're like divisions are also congruent. Okay, and that would be how you would go about proving it. There'd have to be a little bit of stuff about how the definition of midpoint is something that's dividing something in half. So also explain that a midpoint divides a segment into halves. Okay, so that's where we get the divide by 2 or times 1/2. Okay, prove a segment MJ is congruent to segment FH. So let's find MJ. There's MJ and there's FH. So that's this whole segment here. Now we're told that KG bisects both MJ and FH, which means, and we're also told that MK and FG are congruent. So if this is bisecting MJ, and MK is congruent to FG, and this is also bisecting FH, then that means that this and this is half. These are each half of MJ and FH, respectively. So if we doubled them, if I double MK, I get MJ. If I double FG, I get the measure of FH. So by multiplication, okay, because KG bisects MJ and FH. MJ and FH are 2 times the measures of the congruent segments MK and FG. And by multiplication of congruent segments by the same factor, MJ and FH are also congruent. Okay, I hope that gives you what you need. The bottom line is MK and FG are congruent, and we're doubling them to get MJ and FH. We know we're doubling them because KG bisects MJ and FH. And so since we're doubling two congruent things by multiplication, the doublings are also congruent. All right, I hope that helps.